So for this one, we're given a wire. So the picture of what's going on also has already been drawn, which is nice. It's 16 centimeters long. The wire is cut into two pieces. We don't know where they're going to be cut, but each piece is bent and formed into the shape of a square. So we're going to look at one square is maybe bigger than the other. Suppose that the side length in centimeters of one side is x, some unknown value as shown below. Then what we're asked to find is find a function that gives the total area of the enclosed two squares in square centimeters in terms of x. Find the side length of x that minimizes the total area of the two squares. So we've got to use it all. We've got to use a 16, but we want to minimize it. So should we make one really big and one small, or what should we do? So the way we can do this is, first of all, this side, when we make it, each of these side lengths is going to be x, x, x. So it takes 4x to make this triangle, square. It's a square, yeah. The area of this square is going to be x squared. So that's kind of good, easy to see. What we want to see is once we've made this square, then we've got to see what's going to be left to make the other square. Well, we started off with 16 centimeters of wire. We just do 16. Although there's nothing wrong with having the units there, but just knowing that they are. We're going to subtract off, we're using up 4x, whatever that number is. So if it was 1 centimeter, 1 times for each side, that's 4, 16 minus 4, whatever it is. But we're going to leave it as a variable because that's what it is. And what that is, that's how much is left to make this other square. So what is going to be the length of each side on this square? Well, this is what's left. We're going to divide it into 4 pieces, 4 equal pieces to make that square. So 4 goes into, so we have to distribute this to both of these numbers. 16 divided by 4 is 4. 4 divided by 4 is 1. So each of these sides is 4 minus x. Which, that's not so important to go through, but what it does tell us is that the area of this is going to be 4 minus x squared, right? Because the area of a square is the side squared. Now, what's the total area going to be? We add these two together. So our area function, let's just go here, I guess. Area, our function, is going to be x squared plus 4 minus x squared. Okay, we can go ahead and leave that as is and enter that in there. X squared plus, parentheses, 4 minus x squared. Now, yeah, you could FOIL this out. And we'll do that if need be. Oh, there's a couple other questions. The side length x of this in centimeters. What is the minimum area enclosed by the two squares? So here's the deal. If we use a graphing calculator, notice this is a quadratic, we will be able to graph this. What we're looking for a minimum is the vertex. It's going to give it to us. Now I'm going to do that, and we're going to get our answers, and then I'll show you how, if you don't have a graphing calculator, how you can do it by hand. So y equals, let's clear it out. We're going to put in here x squared plus 4 minus x plus the quantity 4 minus x quantity squared. It'll graph it just as it is. That's the nice thing of a graphing calculator. I'm going to do a zoom standard, zoom 6. That's usually what I like to start off with. I just see it there, so it's enough, but I always like to see a little bit more graph than that. So I'm going to go to the window. I'm going to make my y maximum. Let's make it 20. I just want to be able to see more of the graph. Yeah, there. See more of the graph. I need to find what that vertex is, because the x-coordinate of that vertex will give us the side length we should use. And you can see it looks like about 2, but I don't know if it's going to be exact or not. So, but let's do it. Second, calc, minimum. Minimum is the vertex here. I need to put a left boundary, and I've got my little spider flashing right there because I went up high enough. If I didn't go up higher, I would maybe have to move it to the right, which is fine. I get it closer to that minimum value. Hit enter. I need to do a right bound, which means I have to come down into the valley and then back up the other side. There's our minimum. Go up. Don't try to do it too close. Make sure you clearly are on the right side of the boundary. Hit enter. And then we're going to hit enter for the guess. And it's going to look between our two boundary points there. And there it is. 9 with a value of 8. Okay. Sorry, what did I say 9? I said 1.999. That's 2 with y equals 8. X is 2, y is 8. So we come over here. And we can enter that value here as 2, and 8 is the minimum area that we would get. Now, we could plug that in. If you plug in 2, you get 2 squared is 4. Let's just kind of do some scratch work over here. 2 squared is 4. I plug in 2 here. 4 minus 2 is 2. 2 squared is 4. 4 plus 4 is 8. Yeah, it works out. But here's how if I didn't have the graphing calculator, what I would need to do is FOIL this part out. So I would take my x squared. I'm going to FOIL out 4 minus x. Let's do that here. 4 minus x times 4 minus x. You get 16. You get negative 4x. You get negative 4x. And then you get positive x squared. And so I might just kind of combine. I'm going to put the x squared first. Minus 4 is negative 8x plus 16. X squared plus x squared is 2x squared minus 8x plus 16. And that is our function. We don't set it equal to 0 because we're not trying to find the x-intercepts. What we want to find is the vertex. So by hand, the way we find the vertex, again, minus b over 2a, and then the f of minus b over 2a. So we find the x-coordinate and then plug it back into the function. Minus b is negative 8, or b is negative 8, so we get minus negative 8 over 2 times 2. A is 2. So that gives us a negative. Negative is a positive. That gives us 8. Positive 8 over 4. 8 divided by 4 is 2. X equals 2. There it is. And then now we need to plug that back into the function. The area when x equals 2 is 2 times 2 squared minus 8 times 2 plus 16. I got to do all of this. 2 squared is 4. 4 times 2 is 8. 2 times 8 is 16. So this is minus 16 plus 16. Well, negative 16 plus 16, those are 0. Area is 8. Right there. We found it. So you can do this all by hand, manipulating the symbols. That's a symbolic manipulation. That is a way of doing math. We can also do it graphically with our graphing calculator. So your choice. That was, what was that? That was number 10. All right.